The central limit theorem. The central limit theorem. Why are we so concerned with means? Well, there's two reasons. They give us a middle ground for comparison, and they're easy to calculate. So in this chapter, we are going to study means and the central limit theorem. So CLT is what we call the central limit theorem for short. It's one of the most powerful and useful ideas that we use in all of statistics. So there's two alternative forms of the theorem, and both are concerned with drawing finite samples, size n, from a population with a known mean mu and a known standard deviation of sigma. The first alternative says that if we collect samples of size n with a large enough n, we calculate each sample's mean and create a histogram of those means, then the resulting histogram will tend to have an approximate normal bell shape. So we did that last chapter, the normal distribution. The second alternative says that if we again collect samples of size n that are large enough, we calculate the sum of each sample and create a histogram, then the resulting histogram again will tend to have a normal bell shape. So the size of the sample that's required in order to be large enough depends on the original population. So it should be at least 30, or the data should come from a normal distribution. If the original population is far from normal, then more observations would be needed. So sampling is done with replacement in this central limit theorem. It would be difficult to overstate the importance of the central limit theorem in statistical theory. Knowing that data, even if its distribution is not normal, behaves in a predictable way is a powerful tool. So suppose that x is a random variable with a distribution that may be known or unknown, so it can be any distribution. Then these are the subscripts that we'll be using, so the mean of x and the standard deviation of x. And if you draw random samples of size n, as n increases, the random variable x bar, which consists of sample means, tends to be normally distributed. And this is our notation right here. So basically the central limit theorem states that as we get larger and larger samples, such as rolling dice 1, 2, 5, and finally 10 dice and calculating their means, that the sample means are going to start to form a normal distribution. And we will go over an example here in a minute. So to put it more formally, if you draw random samples of size n, the distribution of the random variable x bar, which consists of sample means, is called the sampling distribution of the mean. And the sampling distribution of the mean approaches a normal distribution as the sample size increases.